how we measure performance of the libraries over time. And this also applies to you if you're building a website or a single page app or whatever. One thing we hear quite a bit is something like this. We measured our website. It loads in 6.83 seconds. We need to make it faster. There are a lot of questions that come out of this and things to take into consideration. So, our questions would be, okay, what hardware did you run your website on? What network was it a phone or was it a computer? Was it a fast new laptop or not? What network were you running it on? Was it a home network? Was it a high-speed corporate network? That sort of thing. We're going to talk about this one later, but does your customer care how long it takes to finish loading your website, or are there other metrics that are more important? And then what tools did you use to measure that amount of time? Because tools behave differently as well. So what are you really what's your goal? Like, faster isn't really a goal. It's just, it's an effort. You want to make it faster, but what are you trying to accomplish? What time, what speed, what metric, what's your actual goal? So we try to help them through that process. Particularly, which metrics are important to your users? And your users might be different than somebody else's users. So, for example, if you're providing a tax service where somebody's coming to your website to do their taxes, they are willing to spend more time waiting for your page to load before they bail than if your website was just allowing the user to find a Giphy to share on their Slack channel, right? Like, if you're looking for a Giphy, you're going to bounce back out of that website like under a second if it doesn't load. But if you're doing your taxes, it might be 10 seconds, whatever. This doesn't mean that you shouldn't continually try to improve your speed, but it's contextual, right? Like, what you're after is contextual. So there are a lot of metrics that are available, and I want to mention some of them just so you're aware of them and what they mean. Time to first byte is probably the shortest, the simplest. It's how long does it take to get the first byte back from the server when you request a web page. Time to first paint. So this is the first time anything is rendered on the web page, and that might just be a background color, or it might be some text, but it's the time to the first paint. Then there's time to first contentful paint. So not just a background color, but like some sort of something reasonably useful. So like text or an image or something like that. So let me back up. First paint and first contentful paint may be the same time. It depends on what's painted and if it's the background color that comes in first and then some text, those will be different. But if they both come in at the same time, they might be the same amount of time. So time to first meaningful paint. This one gets a little trickier. If you just display, if you get the background color and then later you get an image on the sidebar, and then you get the content in the middle, that's the main content. Meaningful paint might be that text. But defining what's meaningful is where this term gets confusing and differs between tools. So kind of a newer metric is time to largest contentful paint. So it was kind of hard to define meaningful paint. And so they said, okay, we're going to figure out at what moment in time was the largest thing in the viewable area rendered. And we're going to consider that the largest content. And how long did it take to actually display that largest content in the viewport? And then we have time to interactive. So when can I actually start clicking stuff? When will it react to my mouse or keyboard? This term has kind of changed over time as well. And in part because of this next measure called time to consistently interactive. So it might be that you can click a button, but if nothing reacts, if it stops, you might click a button, it might do something, but it might stop reacting to your interactions after that. And that's not good either. And so consistently interactive was, it's often defined as there's no task, no JavaScript task that runs for over 50 milliseconds over a duration of 5 seconds. So it's consistently interactive because there's no long JavaScript task occurring. But consistently interactive and interactive are kind of interchanged depending on the tool. And then time to visually complete. So when is all the visual stuff loaded? And then one other thing I wanted to mention is all the other ones are typically talking about load times or processes in the load time, but there's also what happens after it loads. So quantity and duration of long tasks is pretty important. If the user's been on your website for 1 minute and they click something and then everything freezes for 20 seconds, that's not good either, even though it's not part of the load time. So we take a look at that as well. So take a look at this. I think this is a really important piece of the puzzle. We have Google search results loading, and we go from empty screen to what would be considered the first paint, although it's nothing useful, right? And then we have the first contentful paint where we have the search bar and some tabs. Does your user, if you did this with your website, does your user consider this useful or sufficient or meaningful? And in some cases, it may deceive you. Like even this first paint, although it doesn't look very useful, it does tell the user that something is loading, which might be sufficient to keep them around until more important information comes along. So keep that in mind as you're trying to determine which metrics are important to your users. I would encourage you to get screenshots of like this and actually take them to your users and say, where do you think you would bail, or what content is important to you? And then we get over here to first meaningful paint and time to interactive. And then you take, when we're trying to define what's meaningful to a user, let's talk about the content for your actual website alone. So here we have YouTube. The main part in this YouTube user experience is the video. And then in Twitter, it's usually the first tweet, and whether it's like the temperature, right? Like that's what they're looking for. And then on a news site, it's the first article that shows up at the top. That's probably where you should focus your time. Not so much on like how long it takes for your total website to load. That's not the important part here. It's what's meaningful to your user. And that's probably where you should focus your time the most. So know your testing environment. Where are you running your tests to determine these metrics? Is the network consistent? If you do it one day and then you do it the next day, is the network going to be consistent? This is probably the hardest part to control, to be honest. Is the hardware consistent? Like, are you trying to run it on a cluster of servers, and then one server might be slower than another server, or have more shared services on it that are doing other things? Same thing with the VMs. If you're trying to run it on a VM, is it on a server with a bunch of other VMs that are doing things and then not doing things and doing things? Because that could play into your test results as well. And is your tool throttling anything like speed or network speed, CPU speed, anything like that? That can always play into your results as well. And often just be aware, like, don't try to optimize for the tool. Define your metrics, make sure the tool supports that, and then focus on the measurements that are important to you. Because sometimes tools will try to emphasize something that may not be actually important to your users. So the hardware, hardware impact. I'm gonna skip over this. I think actually no, I'll cover it. So when you're trying to choose hardware for your tests, here would be an example of one test run. I might have a version 1 of my library and I test it out, and it comes out with the result is 28 milliseconds for that thing to execute. And then we have version 2 of the library, and that takes 30 milliseconds for that library to execute. Well, is that actually 2 milliseconds slower, or could it be random variance? Because you have other things playing into this, like operating system performance and what else it's doing at the same time. And same with the browser, anything like that. And so here we can't really tell if, we can say that it's 8% slower, but we can't tell if it's a slower library because our code changed, or if it's just random variance that's happening on the computer. And so what we have found personally in Adobe is that it's easier to get a signal compared to the noise if we run on a slower hardware. So in our case, we run on a Mac Mini. and that's where we do our performance testing. And we'll do some experiments later on with like Azure VMs and see if we can still tease out the right information. But for now, we run on slow hardware. It's like a 2009 Mac Mini. And this is kind of the impact of that. So it slows down everything. And we found that the random variance as an absolute amount of time doesn't really change much between a fast hardware and slow hardware. But we can still see the variance of the library. And so here, the random variance doesn't account for the difference between 112 milliseconds and 121 milliseconds. So in this case, we can say, okay, it was 8% slower, and we know random variance doesn't cover that, so it's got to be a slower library. So we'll go check our code and figure out what changed. So make sure you do realistic testing. Simulate on real websites, like real setups. So in our case, we might have a commerce website and a news website where we test our libraries and see how they behave in those types of websites. Run the test 30 times minimum. Because of the variance thing, like you want to cut that down as much as possible. So in our case, we run them 100 times before we say, okay, it actually took this long to execute. And then you can actually, if you own a website, you can track performance of the real website for real users using the Performance Observer API that's provided by browsers. And you're getting more and more browser support for that as time goes on. In our case, because our libraries go on customer websites, we just kind of have a policy that we don't send data for our purposes from our libraries that are on customer websites. So it's a little tricky for us, but maybe very good for you. The tool we use for measuring is SiteSpeed.io. It's a great service. There's a lot of tools out there, but SiteSpeed was really great for us for many reasons. It provides Docker images to get set up pretty quickly with being able to test the performance of your website. Provides mobile emulation and custom metrics. That's important because we talked about figuring out which metrics are important to your users. If there's a block of content on your website that you feel is the most important thing that you want to, or one important thing that you want to track, you can set up JavaScript that will say, okay, that will tell SiteSpeed, okay, that thing is done, and then you can report on that particular metric. It also produces videos and screenshots of your website as it loads, which is useful, again, like we talked about, and it produces a JSON file with metrics that you can use with different reporting products. And in this case, it also has like pretty good integration with Grafana, so you can chart it out over time. And it looks something like this. So this is a dashboard with multiple metrics over here, and just charts it over time. You know, you can see how it changed over each date. And if you have a spike, you can kind of drill into that and figure out if it's a problem with JavaScript performance or just something else that was happening that day. And there's so much more information I'm not showing on this screen. Anyway, that's how we tackle JavaScript performance. There's a lot more things to focus on as well. Those are just some of the highlights.